Now, in this lecture, we will find out the length of chord AB. In the drawing, we have semicircle, and inside this semicircle, we have three circles. Those two small circles are identical, and in the middle, we have the middle circle. The middle circle, this middle circle is tangent to the center of the semicircle, that is to say to point O. Point O is the center of the semicircle, and point C is the center of the middle circle, of this middle circle, and so we will define the center of the small circle. This small circle is point M. We also know that PQ, that is actually the diameter of this semicircle, equals to 8 units. And the diameter of any circle is twice as large as the radius. So if the diameter PQ equals to 8 units, then the radius of the semicircle will be equal half of it, that is to say it will be equal to 4 units. That is to say that the radius PO of the semicircle will be equal to 4 units. And OQ, this line segment OQ, it is also the radius of this semicircle, because it starts from the center of the semicircle and ends at point Q, that is a point on the semicircle itself. Therefore OQ is the radius of the semicircle, that is to say it equals to 4 units. Then we will join together points M and C by a straight line. M and C are the centers of the circles. M is the center of the small circle, and N and C is the center of the middle circle. And the distance between the centers of two circles that have an internal and external lunge between them, like in this drawing, the small circle and the middle circle have an external lunge between them, and we will define the touching point between the small circle and the middle circle. This point is point Y. So the distance between the centers of two circles that have an external lunge between them, it is actually equals to the sum of the length of their radiuses. So if we define the radius of this small circle as R, then the length of the radius is R units, and we know that OX, it is the radius of the semicircle, that is to say, therefore it equals to 4 units, but OX, it is also the diameter of this middle circle, and the diameter is twice as large as the radius. So if the diameter OX equals to 4 units, then the radius of this middle circle will be equal to 2 units. That is to say CX equals to 2 units, and CO also equals to 2 units. And CY, it is also the radius of this middle circle, therefore it equals to 2 units. So the length of the radius of the middle circle equals to 2 units. So in total, the distance between points M and C will be equal to R plus 2. So MC equals to R plus 2. And then we will define the touching point between tangent PQ and this small circle is point N, so this point equals to, it is defined as N. Then we will join together points M and N by a straight line. Actually, MN is the radius of this small circle because line segment MN starts from the center of the small circle, that is to say from point M, and ends at point N, that is a point on the small circle itself. Therefore, MN is the radius of this small circle, that is to say it equals to R. And we have the radius, this radius MN is drawn to the point of tangency, that is to say it is drawn to point N, that is the point of tangency of tangent PQ with this small circle. Therefore, the tangent PQ is perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Why? Because whenever you have a radius that is drawn to the point of tangency, point N is the point of tangency, and the radius MN is drawn to the point of tangency, therefore the tangent PQ is perpendicular to this radius. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we know that CO is the radius of this middle circle, that is to say it equals to 2 units, and point O is the point of tangency between tangent PQ and this middle circle, and we have the radius CO is drawn to the point of tangency, that is to say it is drawn to point O, that is the point of tangency. Therefore, the tangent PQ will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? So in the next step, we will draw perpendicular to CO from point M. I repeat, from point M, we will draw perpendicular to CO. So this line is perpendicular to CO, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees because this line is perpendicular to CO. We will define the touching point between the perpendicular from point M to CO as point D, and then we know that AB is parallel to PQ. I repeat again, AB, the chord that you are looking for, AB is parallel to PQ, and we have a rule that states that corresponding angles between parallel lines are equal to each other. So those two angles, they are corresponding angles and they are located between the parallel lines AB and PQ, therefore they are equal to each other. So this angle is the right angle, it equals to 90 degrees, therefore this angle will be also equal to 90 degrees, it is a right angle. Likewise, we have those two angles are corresponding angles, that is to say they are corresponding angles and they are located between the parallel lines AB and PQ, therefore they are equal to each other. But we know that this angle is 90 degrees, so this angle will be also equal to 90 degrees. Okay? And I will copy again. As you can see from the drawing, quadrilateral MN DO has 3 right angles, 1, 2, 3. So I will copy again the quadrilateral and the right triangle CDM. We will define this point as point E. So I copied again the quadrilateral NO DM. I copied again the quadrilateral MNDO and the right triangle CDM, and also the right triangle CEY. And here quadrilateral MDON has 3 right angles, 1, 2, 3. So the sum of those 3 right angles is 90 times 3 is 270 degrees, plus the size of this angle that we will define as angle X. So the sum of those 4 angles must be equal to 360 degrees according to the following rule. According to rule number 1, it states that the sum of the angles in any quadrilateral equals to 360 degrees. So rule number 1 states that the sum of the angles in any quadrilateral equals to 360 degrees. So I will read rule number 1 again. Rule number 1 states that the sum of the angles in any quadrilateral equals to 360 degrees. So the sum of the angles in quadrilateral MNOD equals to 360 degrees. That is to say, the sum of those three angles, that is actually 270 degrees, plus the sum of the fourth angle, that is angle X, must be equal to 360 degrees according to number 1. Again, 270 degrees plus the size of angle X must be equal to 360 degrees according to rule number 1. So here we will subtract 270 degrees from this equality, and we will get that angle X equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that this angle is a right angle, it equals to 90 degrees. So actually all four angles of quadrilateral MDON are right angles, they are equal to 90 degrees. And we also have rule number 2. According to rule number 2, a quadrilateral with four right angles must be at least a rectangle. I write it down. According to rule number 2, a quadrilateral that has four right angles must be at least a rectangle, if not a square. So I will read rule number 2 again. Rule number 2 states that a quadrilateral that has four right angles must be at least a rectangle, if not a square. Okay, so our quadrilateral MDON that has four right angles, it must be at least a rectangle. And we also have rule number 3. Rule number 3 says that the opposite sides of a rectangle are equal to each other. According to rule number 3, the opposite sides of a rectangle are equal to each other. I'll read rule number 3 again. Rule number 3 states that the opposite sides of a rectangle are equal to each other. So here, from the drawing, you can see that MN equals to R. It is the radius of this small circle. So here, MN equals to R. And according to rule number 3, that the opposite sides of a rectangle are equal to each other, so the opposite sides of rectangle M, D, and O are equal to each other. That is to say, MN equals to DO. Okay, according to rule number 3 that says that the opposite sides of a rectangle are equal to each other, MN equals to DO. MN is equal to DO. I will repeat again. Side MN of rectangle MNOD is equal to side DO, according to rule number 3 that the opposite sides of a rectangle are equal to each other. But we know that MN equals to R. MN equals to R, it is the radius of the small circle. So from this equality, we will get that R equals to DO. That DO also equals to R. DO equals to R. DO equals to R. So here DO equals to R, and we actually know that CO is the radius of the middle circle. You can see here that CO it is the radius of the middle circle, therefore it equals to 2 units. CO equals to 2 units, so we can write here that CO, that is the radius of the middle circle, equals to 2 units. And DO equals to R. CO minus DO equals to CD. CO minus DO equals to CD. Again, CO minus DO equals to CD. Okay, CO minus DO equals to CD. But CO equals to 2 units and CD equals to R. It is the radius of the small circle. Therefore, we found out that CD equals to 2 minus R. CD equals to 2 minus R. So CD equals to 2 minus R, and DO equals to R. And what is the value of MC? We have already found out that MC, here, MC, that is the distance between the centers of the small circle and the middle circle, here, MC equals to R plus 2. MC equals to R plus 2. So here, the hypotenuse MC equals to R plus 2. And CD equals to 2 minus R, so we will focus on the right triangle CDM. On the right triangle CDM, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, according to the Pythagoras theorem, in any right triangle, and especially in the right triangle CDM, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse of the right triangle CDM is MC. So MC, the square of the hypotenuse is MC squared. And MC squared, it equals to the sum of the squares of the perpendiculars. That is to say, it equals to CD squared plus MD squared. I will repeat again. According to the Pythagoras theorem, in the right triangle CDM, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, MC square equals to CD square plus MD square. Okay, so what is the value of MC? We have already found out that MC equals to R plus 2. If MC equals to R plus 2, then MC square will be equal to R plus 2 square. And it equals to CD square. CD equals to 2 minus R, so CD square will be equal to 2 minus R squared plus MD square. So CD square is R plus 2 square. It equals, it is actually CM square, it is MC square. MC equals to R plus 2, so MC square equals to R plus 2 square. And it equals to CD square. CD equals to 2 minus R, therefore CD square equals to 2 minus R square plus DM square. So here we will open the brackets on both sides of equation number 1, and we will get that R plus 2 square R plus 2 square, it is actually R square plus 4R, and it equals to 2 minus R square. 2 minus R square, it is actually equals to 4 minus 4r plus r squared plus md squared. So here we have r squared on both sides of equation number 1, this equation, so r squared will get cancelled. And we also have 4 on both sides of this equation, equation number 1, so 4 will also get cancelled. And what is left from equation number 1 after we cancel those expressions, what is left, it is actually here in this side of equation number 1 is 4r. On the other side of equation number 1, what is left, it is actually here, it is actually, I made a mistake here, it is minus 4r. 2 minus r squared, it is 4 plus r squared minus 4r. So what is left on the other side of equation number 1 is minus 4r plus md squared. So here we will add 4r to this equation, equation number 1, and we will get that 4r plus 4r is 8r. 8r equals to 4r minus 4r is 0, so 8r equals to md squared. 8r equals to md squared. So here we will take a root out of equation number 1, and we will get that md equals to the square root of 8r. But we know that 8 equals to 4 times 2, so we'll substitute 8 by 4 times 2. And we will get that md equals to the square root of 4 times 2 times r. Here the square root of 4 is 2. The square root of 4 is 2, so I'll write it down. We will get that according to equation number 1, md equals to 2 times square root of 2r. So we actually found out that md equals to 2 times square root of 2r. So we can write here that md equals to 2 times square root of 2r. And we have rule number 3 that states that the opposite sides of a rectangle are equal to each other. Therefore, MD will be equal to NO. MD equals to NO according to rule number 3 that the opposite sides of a rectangle are equal to each other. Again, MD equals to NO according to rule number 3. But we have already found out that MD equals to 2 times square root of 2R. So we'll write it down, that MD equals to 2 times square root of 2R. So from this equality, we will derive that NO also equal to 2 times square root of 2R. NO equals to 2 times square root of 2R. So we can write here that NO equals to 2 times square root of 2R. Okay? In the next step, we will connect together points M and O by a straight line. So what is the value of MO? The value of MO from the drawing, first of all we will connect together points M and O by a straight line. Then we will connect together points M and A by a straight line. As you can see from the drawing, AM is the radius of this small circle, that is to say it equals to R. And we know that OA is the radius of the semicircle, that is to say it equals to 4 units. So OA equals to 4 units and AM equals to R, it is the radius of the small circle. You can see from the drawing easily that MO equals to AO minus AM. Again, AO minus AM equals to MO. AO minus AM equals to MO. So MO equals to AO is 4 units and AM is R. So in total we found out that MO equals to 4 minus R. So we can write here that MO equals to 4 minus R. And we will write here that MO, the hypotenuse of triangle M and O, equals to 4 minus R. Okay. So we will focus on the right triangle M and O. We will focus on the right green triangle, triangle M and O. So on the right green triangle, triangle M and O, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the square of the hypotenuse is MO, therefore the square of the hypotenuse is MO squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to MN squared plus NO squared. I will repeat again. In the right triangle, triangle M and O, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, MO square equals to MN square plus NO square. But we have already found out that MO equals to 4 minus R, so MO square will be equal to 4 minus R square. Okay, MO square equals to 4 minus R square, and it equals to MN square. MN equals to R. Therefore, MN square will be equal to R square plus NO square. NO equals to 2 times square root of 2R. So NO square will be equal to 2 times square root of 2R square. Okay. So I will repeat again. MO equals to 4 minus R, therefore MO square equals to 4 minus R square. MN equals to R, therefore MN square equals to R square. NO equals to 2 times square root of 2R, therefore NO square equals to 2 times square root of 2R square. Here we will open the brackets on both sides of equation number 2, and we will get that four minus R square is 16 minus 8R plus R square, and it equals to R square plus 2 times square root 2R square. It is actually 2 square is 4, and the square of root 2R is 2R, so 4 times 2R is 8R. In total, this expression equals to 8R. So here we have R squared in both sides of this equation, equation number 2, so R squared will get cancelled. we will add 8r to this equation number 2, and we will get that 16 equals to 8r minus 8r is 0, and there 8r plus 8r is 16r. So here we will divide the equation number 2 by 16, and we will get that r equals to 1 unit. R equals to 1 unit. So here we found out that the radius of the small circle equals to 1 unit. So here we can write down that r equals to 1, and CD equals to 2 minus r, and r is 1, so 2 minus 1 is 1. So CD also equals to 1 unit, and in the next step we will focus on right triangle CEY and on the right triangle CTM. Okay, we will focus on the right triangle CEY and on the right bigger triangle CDM. And we will actually prove that those two right triangles are similar to each other. Okay, so we will focus on the right triangle, triangle CEY, and the right triangle, triangle CDM. We know that those two angles, they are equal to each other, they are both right angles, so angle CEY in the green triangle equals to angle CDM in triangle CDM, and they are both equal to 90 degrees. I will repeat again. Angle CEY of triangle CEY equals to angle CDM of triangle CDM, and they are both right angles, they are equal to 90 degrees. And we also have this angle, angle C is a common angle. Angle C belongs to the green triangle, and this angle, angle C, belongs also to the right triangle, triangle CDM. Therefore, we can write down that angle C equals to angle C is a common angle that belongs to both triangles. I will repeat again. Angle C equals to angle C is a common angle that belongs to both triangles. And we also know that those two angles, they are equal to each other. Those two angles are equal to each other according to third angle theorem. So we write down that angle CYE, this angle in triangle CYE, equals to angle CMD in triangle CDM according to third angle theorem. I will repeat again. Angle CYE equals to angle CMD. Those two angles, they are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. So here we have the first pair of angles that congruent are those angles. They are both right angles. The second pair of angles that congruent is this angle. This angle is a common angle, that is to say it equals to itself. So we have two pairs of angles that congruent in those two triangles. Therefore the third pair of angles, those are the third pair of angles, must also congruent according to third angle theorem. Okay, so those two angles are equal to each other according to third angle theorem. So we actually proved that all three angles in triangle CYE, 1, 2, 3, are congruent to all three angles of triangle CDM. Therefore, we actually proved that triangle CYE is similar to triangle CDM according to angle similarity rule. So I write it down. We can conclude that triangle CYE is similar, this is the sign of similar, to triangle CDM, and those two triangles similar to each other according to angle similarity rule. I will repeat again. Triangle CYE is similar to triangle CDM according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle congruent to all three angles in another triangle, then you actually proved that those two triangles are similar to each other according to angle similarity rule. Okay, and from the fact that triangle CYE is similar to triangle CDM, we will conclude that the following equality is true. We will actually conclude that CE over CY in the green triangle CYE CE over CY in triangle CYE CE over CY in triangle CYE equals to CD over CM in triangle CDM equals to CD over CM in triangle CDM. Okay, CE over CY in triangle CY equals to CD over CM in triangle CDM. Okay. But what is the value of CY? You can see here that the value of CY, it is actually here CY, it is equal to 2 units. It is actually the radius of the middle circle. So CY equals to 2 units. So we can write down that CE over CY, that is 2 units. Okay, here CE over CY is 2 units. And what is the value of CD? The value of CD, it is actually 1 unit. We already found out that CD equals to 1 unit because it is 2 minus R and R is 1. So 2 minus 1 is 1. CD over CM. What is the value of CM? CM equals to R plus 2 and R is 1. R plus 2 and R is 1. So 1 plus 2 is 3. So CM equals to 3. So in total we got that C over CY equals to CD over CM. So CE over 2 equals to 1 over 3. Here we will multiply equation number 3 by 2, and we will get that CE equals to 2/3 or 2 over 3 units. So we can write here that CE equals to 2 over 3. And what is the value of DE? DE equals to CD minus CE. DE, you can see from the drawing that DE equals to CD minus CE. Okay, DE equals to CD minus CE. That is to say, DE equals to CD, that is 1 unit, minus CE, that is 2 over 3 units. So DE equals to 1 minus 2/3. 1 minus 2/3 is 1/3. So we found out that DE equals to 1 over 3. DE equals to 1/3. DE or ED equals to 1/3, 1 over 3. And what is the value of line segment OE? The value of line segment OE, it is actually OD plus DE. So OE equals to OD plus DE. So OE Okay, so we'll repeat again. OE equals to OD plus DE. But we know that OD equals to R, it is equals to 1. OD equals to 1, and we already found out that DE equals to third. So OE equals to 1 plus third. 1 plus third is 4 over 3. So OE equals to 4 over 3. OE equals to 4 over 3. So we can write here that OE equals to 4 over 3. In the next step, we will join together points O and B by a straight line. And what is the size of angle OEB? What is the size of this angle, angle OEB? We have the rule that states that the sum of the angles on one side of a straight line equals to 180 degrees. So if we look on this side of point E, then the sum of its angles must be equal to 180 degrees. And we have already, we know that this angle is a right angle, it equals to 90 degrees. And the sum of the angles on one side of point E must be equal to 180 degrees. So this angle, angle OEB, must be equal to 90 degrees in order to complete the sum of the angles in this side of point E to 180 degrees. 90 degrees plus 90 degrees equals to 180 degrees. So angle OEB is a right angle, therefore triangle OEB is a right triangle. So I will copy again the right triangle, triangle OEB, and we will calculate all the sides of the right triangle, triangle OEB. So I copied triangle OEB. We have already found out that side OE equals to 4 over 3 units. OB is the radius of the semicircle, therefore it equals to 4 units. And the only thing that is left to do is to calculate the value of EB, and we will find out the value of EB according to the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here the square of the hypotenuse, so in the right triangle, triangle OEB, the square of the hypotenuse, that is to say OB square, the hypotenuse is OB, equals to the sum of the squares of the perpendiculars equals to OE square plus EB square. So I'll repeat again. In the right triangle OBE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OB square equals to OE square plus EB square. But we know that OB equals to 4 units, therefore OB square will be equal to 4 square. 4 square is 16. And it equals to OE square. OE equals to 4 over 3, so OE square will be equal to 4 over 3 square plus EB square. Okay, I'll repeat again. OB square is 16, OE square equals to 4 over 3 square, and EB square is AB square. 4 over 3 square is 16 over 9, so I will write it down. So 16 according to equation number 4, 16 equals to 16 over 9 plus EB square. Here we will subtract 16 over 9 from this equation, equation number 4, and we will get that 16 minus 16 over 9 equals to EB square. So here we will multiply 16 by 9 and then we will divide it by 9 in order to have a common factor with minus 16 over 9. So we will get that 16 times 9 over 9 minus 16 equals to EB square. Here 16 times 9 minus 16 is 16 times 8 over 9 equals to EB square. So we know that 16 is 8 times 2, so we'll substitute 16 in this equation number 4 by 8 times 2. So we get that according to equation number 4, 2 times 8 over 9 equals to EB square. So we substituted 16 by 2 times 8, we got this expression. Here we will take a root out of this equation, equation number 4, and we will get that EB equals to the square root of 2 times 8 over 9. So the square root of 8 times 8 is 8 and the square root of 9 is 3, so I will write it down. We will get that EB equals to 8 over 3 times square root of 2. So we found out that EB equals to 8 over 3 times square root of 2 units. So in the next step we will prove that those two right triangles can go into each other. So we will prove that the right triangle OEB is congruent to the right triangle OEA. So I will copy those two green triangles and we will prove that they can go into each other. Okay? So we will prove that the right triangle OEB is congruent to the right triangle OEA. And first of all, we know that AO equals to OB equals to 4 units. AO equals to BO. BO equals to 4 units. They are the hypotenuses of those two right triangles, and they are also the radiuses of the semicircle, therefore they are equal to each other. And we also have side OE is a common side, it belongs to both triangles, so OE equals to OE is a common side that belongs to both triangles. And that's it, we actually proved the triangle OEB is congruent to triangle OEA according to rule number 4. What is rule number 4? Rule number 4 states that if the hypotenuse and a perpendicular in one right triangle congruent to the hypotenuse and a perpendicular in another right triangle, then the right triangles congruent to each other. Congruent to each other. I will repeat on rule number 4 again. According to rule number 4, if the hypotenuse and the perpendicular in one right triangle congruent to the hypotenuse and a perpendicular in another right triangle, then the right triangles congruent to each other. So we actually proved that the hypotenuse OB and the perpendicular OE in the right triangle OEB are congruent to the hypotenuse OA and the perpendicular OE in the right triangle OEA. Therefore, we actually proved that those two right triangles congruent to each other according to rule number 4. Okay, and from the fact that those two triangles congruent to each other, we will conclude that AE equals to EB. AE equals to EB, and actually AE equals to EB according to the rule that corresponding sides and congruent triangles are equal to each other. Those two right triangles congruent to each other, therefore the two corresponding sides, that is to say AE and EB, will be equal to each other. Therefore AE equals to EB. And what is the value of AB? The value of AB from the drawing you can see that AB equals to AE plus EB. AE plus EB. I will repeat again. You can see from the drawing that AB equals to AE plus EB. But we have already found out that AE equals to EB, so actually AE, we can substitute AE by EB and we will get that AB equals to, we substitute AE by EB, AB equals to EB plus EB. That is to say AB equals to 2 times EB. And we have already found out that EB equals to 3 over 8 times square root of 2 units. So in total we found out that AB equals to 2 times 8 over 3 times square root of 2 units. In total we found out that AB equals to 2 times 8 is 16 over 3 times square root of 2 units. So actually AB equals to 16 over 3 times square root of 2 units, or in terms of numbers, AB equals to 7.54 units. AB equals to 16 over 3 times square root of 2 units, or in terms of numbers, AB equals to 7.54 units. Okay, I repeat again. In the drawing, AB chord AB equals to either 16 over 3 times square root of 2 units, or in terms of numbers, chord AB equals to 7.54 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the size of AB, or the length of AB, and we have here a semicircle, and inside the semicircle we have 3 circles. Those 2 circles are identical, and the middle circle is tangent to the center of the semicircle at point O. So point O is the center of the semicircle, and point C is the center of the middle circle, of this circle. And we also know that PQ equals to 8 units. PQ is the diameter of the semicircle, and the diameter is twice as large as the radius. So if the diameter equals to 8 units, then the radius must be equal to 4 units. So the radius of the semicircle, PO, equals to 4 units, and the radius OQ, that is the radius of the semicircle, it is also equals to 4 units, and OX, that is also the radius of the semicircle, equals to 4 units. But OX, it is not only the radius of the semicircle, but is also the diameter of the middle circle. So we know that the diameter of the middle circle equals to 4 units, and the diameter is twice as large as the radius. So if the diameter of the middle circle equals to 4 units, then the radius of the middle circle will be equal to 2 units. That is to say, CX, that is the radius of the middle circle, equals to 2 units, and CO, that is also the radius of the semicircle, equals to 2 units, and CY, that is also the radius of the middle circle, equals to 2 units. And we defined the center of the small circle as point O, and so we know that CY is the radius of the small circle. We define the radius of the small circle as R, so CY equals to R. Then we join together points M and N by a straight line. Point N is the point of tangency of tangent PQ with this small circle, and we have this radius, the radius MN, is drawn to the point of tangency, that is to say, it is drawn to point N. Therefore, the tangent PQ will be perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we have the radius CO of the middle circle that is drawn to the point of tangency, that is to say, it is drawn to point O, that is the point of tangency of tangent PQ with this middle circle. Therefore, according to the rule that I mentioned, the tangent PQ will be perpendicular to this radius CO. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Then I draw perpendicular from point M to CO, the radius of the middle circle. So this is perpendicular to CO, that is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. We defined that the touching point between the perpendicular to CO is point D. And we know that AB is parallel to PQ, and those two angles, angle POX and angle AEX, those two angles, they are corresponding angles that are located between the parallel lines AB and PQ. Therefore, they are equal to each other. Those two angles are equal to each other, but we know that this angle POX equals to 90 degrees, therefore angle AEX will be also equal to 90 degrees. Likewise, we can see it from the other side. Those two angles are corresponding angles, angle QOX and angle BEX. They are corresponding angles that are located between the parallel lines AB and PQ. Therefore, they are equal to each other. So, but we know that this angle equals to 90 degrees, so this angle also must be equal to 90 degrees. That is to say, angle BEX is a right angle, it equals to 90 degrees. Okay, then I draw again the quadrilateral NOD MNOD and the right triangle CDM, and so we have here the quadrilateral MNOD and the right triangle CEY and also the right triangle CDM. In quadrilateral MDON we have three right angles, 1, 2, 3. And the sum of those three right angles is 90 times 3 is 270 degrees, plus this angle that we defined as angle X must be equal to 360 degrees according to rule number 1 that states that the sum of the angles in any quadrilateral equals to 360 degrees. I will repeat again. According to rule number 1 that the sum of the angles in any quadrilateral equals to 360 degrees, if we focus on quadrilateral MDON, then the sum of its angles equals to 360 degrees. That is to say, the sum of the three angles, that is 270 degrees, plus angle X must be equal to 360 degrees according to rule number 1. We subtracted 270 degrees from this equality and we got that angle X is 360 degrees minus 270 degrees. Angle X equals to 90 degrees. That is to say, angle X is a right angle. It equals to 90 degrees. Okay, so this angle is a right angle. It equals to 90 degrees. So as you can see from the drawing, all four angles of quadrilateral MDON are right angles. And we have rule that states, rule number 2 states that according to rule number 2, quadrilateral that has four right angles must be at least a rectangle, if not a square. And because of the fact that quadrilateral MDON has four right angles, it must be at least a rectangle, if not a square. Okay? And we have also rule number 3 that states that the opposite sides of a rectangle are equal to each other. Okay? And we know that MN is the radius of the circle. A small circle is equals to R. So according to rule number 3 that states that the opposite sides of a rectangle are equal to each other, we will get that MN equals to DO, but we know that MN equals to R. Mn equals to DO according to rule number 3 that the opposite sides of a rectangle are equal to each other, but we know that Mn equals to R. So from this equality we will get that R also equals to DO, DO equals to R. So we can write here that DO equals to R, and then what is the value of CD? CD equals to CO, it equals to CO minus DO. CD equals to CO minus DO. We know that CO is the radius of the middle circle, that is to say it equals to 2 units, and DO is the radius of the small circle, that is to say it equals to R. So in total we found out that CD equals to 2 minus R. So here CD equals to 2 minus R. Okay, then, and what is the value of CM? We have already found out that CM, that is the distance between the centers of the small circle and the middle circle, it is actually R plus 2. So we found out that the hypotenuse of the right triangle CDM is R plus 2, and the perpendicular CD it equals to 2 minus R. And then we implemented the Pythagoras theorem on the right triangle CDM. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, MC square equals to CD square plus MD square in the right triangle CDM. MC square equals to CD square plus MD square. Then we know that MC equals to R plus 2, so MC square equals to R plus 2 square, and it equals to CD square. CD equals to 2 minus R, so CD square equals to 2 minus R square plus MD square. We open the brackets on both sides of equation number 1, this equation, and we found out that R plus 2 square, it is actually R square plus 4R, and 2 minus R square, it is actually 4 minus 4R plus R square plus MD square. Here we have R square on both sides of equation number 1, so R square will get cancelled, and we have 4 on both sides of equation number 1, so 4 will also get cancelled. What is left from equation number 1 after we cancel those two expressions? What is left, it is actually in this side of equation number 1, we have only 4R left, and on the other side of equation number 1, what is left, it is actually minus 4R plus MD square. We added 4R to this equation, equation number 1. So here 4R plus 4R is 8R. And 4R minus 4R is 0. So what is left here, 8R equals to MD square. Here we took out a root of equation number 1, and we got that MD equals to the square root of 8R. We know that 8 is 4 times 2, so we substituted 8 by 4 times 2, and we got that MD equals to the square root of 4 times 2R. But the square root of 4 is 2. So in total we got that MD equals to 2 times square root of 2R. So here we can write that MD equals to 2 times square root of 2R. But we have also rule number 3 that states that the opposite sides of a rectangle are equal to each other. That is to say, MD equals to NO. MD equals to NO, according to rule number 3. But we know that MD equals to 2 times square root of 2R. So from this equality we will conclude that NO also equals to 2 times square root of 2R. So here NO equals to 2 times square root of 2R. Okay? And then we join together points M and O by a straight line, and we calculated the value of MO from the drawing. From the original drawing, we join together points M and O by straight line. We join together points M and A by straight line. What is AM? You can see from the drawing that the AM is the radius of the small circle, that is to say it equals to small r. What is the value of OA? The value of OA is the radius of the semicircle. It starts from the center of the semicircle, that is to say from point O, and ends at point A, that is the point on the semicircle itself. Therefore, OA is the radius of the semicircle, that is to say it equals to 4 units. So OA minus OM equals to MO. Okay, OA minus MA or AM equals to MO. You can see it from the drawing. OA equals to 4 units, AM equals to R. So in total we got that OM equals to 4 minus R. OM equals to 4 minus R. OM, the hypotenuse of M and O, of triangle M and the right triangle M and O equals to 4 minus R. And we already found out that NO equals to 2 times square root 2R, and MN is the radius of the small circle. So we focused on the green right triangle M and O, and we implemented the Pythagoras theorem on the right green triangle M and O. According to the Pythagoras theorem, the square of the hypotenuse of any right triangle equals to the sum of the squares of the perpendiculars. So in the right triangle M and O, according to the Pythagoras theorem, the square of the hypotenuse is MO square, and it equals to the sum of the squares of the perpendiculars, that is to say it equals to MN square plus NO square. OM equals to 4 minus R, so OM square equals to 4 minus R square, and it equals to MN square. MN is R, so MN square is R square, and ON equals to 2 times square root of 2R. So M and O square will be equal to 2 times square root of 2R square. So here we open the brackets of this equation number 2, and we found out that 4 minus R square is 16 minus 8R plus R square. It equals to R square plus the square of 2 times square root of 2R is 8R. So here we have R square on both sides of equation number 2, so R square will get cancelled. After we cancelled R square, we added 8R to this equation number 2. 8R minus 8R is 0, and 8R plus 8R is 16R. So in total we got that 16 equals to 16R. We divided the equation number 2 by 16, and we found out that the radius of the small circle R equals to 1 unit. So here we found out that R equals to 1, and here CD that equals to 2 minus R, that is to say CD equals to 2 minus 1, 2 minus 1 is 1, so CD equals to 1 unit, and MC, the hypotenuse of the right triangle CDM, equals to R plus 2, and R is 1, so MC equals to 3 units. Okay? Then we actually proved that the right triangle CEY, green right triangle CEY, is similar to the right triangle CDM. It's similar to this right triangle CDM. Why they are similar to each other? Because they have 2 angles that are equal to each other, 2 right angles. Those 2 angles, they are right angles and they are equal to each other. So angle CEY equals to angle CDM. They are both equal to 90 degrees. They are right angles. And we also have this angle C is a common angle. It belongs both to the green triangle, and angle C also belongs to triangle CDM. So angle C equals to itself as a common angle. Angle C equals to angle C as a common angle. And those 2 angles, They are equal to each other according to third angle theorem. Okay, they are equal to each other according to third angle theorem. And what is third angle theorem? Third angle theorem is that if you have a triangle that has if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. Here we have the first pair of angles that congruent. Those two angles are both right angles, they congruent, and we have this common angle, it equals to itself, so this is the second pair of angles that congruent. Therefore, because of the fact that we have two pairs of angles that congruent in those two triangles, then the third pair of angles must also congruent, that is to say these two angles are equal to each other. That is to say angle CYE equals to angle CYE equals to angle CMD according to third angle theorem. So we actually proved that all three angles 1, 2, 3 of triangle CYE equals to all three angles of triangle CDM 1, 2, 3. And therefore we actually proved that triangle CYE is similar, this is the sign of similar, triangle CYE is similar to triangle CDM according to angle similarity rule. And what is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle congruent to all three angles in another triangle, then we actually prove that those two triangles are similar to each other according to angle similarity rule. And from the fact that triangle CYE is similar to triangle CDE, we will conclude that the following equality is true. We will conclude that CE over CY in triangle CYE equals to CD over CM in triangle CDM. I will repeat again. CE over CY in the green triangle is equal to CD over CM in triangle CDM. Okay? But what is CY? CY already showed you that CY is the radius, CY is the radius of the middle circle, it equals to 2 units. So CY equals to 2 units. And CD, we have already found out that CD equals to 1 unit. And CM equals to R plus 2 and R equals to 1, so CM equals to 3 units. CM equals to 3 units. So in total we got that C over 2 equals to 1 over 3. We multiplied the equation number 3 by 2 and we got that CE equals to 2 over 3. So here CE equals to 2 over 3 or 2/3. And what is the value of ED or DE? It equals to CD minus CE. DE equals to CD minus CE. We have already found out that CD equals to 1 and CE equals to 2/3. In total, DE equals to 1 minus 2/3, that is to say DE equals to 1/3. So we wrote here that DE equals to 1/3. And what is the value of OE? The value of OE equals to OD plus DE. Okay, so OE equals to OD plus DE. OD plus DE. And OD equals to 1. It is the radius of the small circle. And we already found out that DE equals to 1/3. In total, we found out that OE equals to 1 plus 1/3. That is to say, OE equals to 4 over 3 units. Okay, OE equals to 4 over 3 units. Then we connected together points O and B by a straight line. And we calculated the size of angle OEB, the size of this angle. Actually, we have the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So if we focus at point E on this side of point E, the sum of the angles at point E on this side of the straight line OX must be equal to 180 degrees. That is to say, we have already found out that this angle is 90 degrees plus this angle. The sum of those two angles must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles from one side of a straight line equals to 180 degrees. So actually this angle must be equal to 90 degrees in order to complete the sum of the angles on this side of the straight line OX around point E to 180 degrees. So if this angle is 90 degrees, this angle must be also equal to 90 degrees in order to complete the sum of the angles on one side of point E to 180 degrees. So this angle is a right angle, it equals to 90 degrees. And if this angle OED is a right angle, then triangle OEB is a right triangle. So I copied the right triangle OEB. Again, we know that OE is equal to 3 over 3 units, we already found out. And OB is the radius of the semicircle, it equals to 4 units. The only thing that is left to calculate is to calculate the value of side EB. We did it according to the Pythagoras theorem that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle, triangle OEB, OB square equals to OE square plus EB square. OB equals to 4. Therefore OB square is 4 square. 4 square is 16. OE equals to 4 over 3 units. So OE square equals to 4 over 3 square. EB square is EB square. So 16 equals to 4 over 3 square is 16 over 9 plus EB square. We subtracted 16 over 9 from this equation, equation number 4, and we got that 16 minus 16 over 9 equals to EB square. Here we multiplied 16 by 9 and then we divided it by 9 in order to have a common factor with 16 over 9. So in total we got that 16 times 9 over 9 minus 16 equals to EB square. 16 times 9 minus 16 is 16 times 8. So in total we got that 16 times 8 over 9 equals to EB square. We know that 16 is 8 times 2, so we substituted 16 by 8 times 2. And we got that so we substituted 16 by 2 times 8, so in total we got that 2 times 8 over 9 equals to EB square. Here we took a root out of equation number 4, and we got that EB equals to the square root of 2 times 8 over 9. The square root of 8 times 8 is 8, and the square root of 8 is 3. So in total we got that EB equals to 8 over 3 times square root of 2 units. So we found out the value of EB. Then we actually proved that those two green right triangles can go into each other. So I copied the two green triangles in this new page, and we proved that those two right triangles can go into each other. Why they can go into each other? Because OB equals to OA equals to 4 units. They are the radiuses of the semicircle, therefore they are equal to 4 units both. And OE is a common side, it belongs to both right triangles. So OE equals to OE is a common side that belongs to both triangles. So in this way we actually proved that those two triangles can go into each other, and we proved that they can go into each other according to rule number 4. What is rule number 4? Rule number 4 states that if the hypotenuse and a perpendicular in one right triangle congruent to the hypotenuse and a perpendicular in another right triangle, then the right triangles congruent to each other. And we actually proved exactly what rule number 3 demands. We proved that the hypotenuse OB and the perpendicular OE in the right triangle OEB is congruent to the hypotenuse OA and the perpendicular OE in the right triangle OEA. Therefore, we prove that those two right triangles congruent to each other according to rule number 4. And for the fact that they are congruent to each other, we will conclude that AE equals to EB according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides AE and EB will be equal to each other. Okay? Therefore AE equals to EB according to the rule that corresponding sides in congruent triangles are equal to each other. And what is the value of AB? The value of AB, it is actually AB equals to AE plus EB, as you can see from the drawing, AB equals to AE plus EB. But we have already found out that AE equals to EB, so we can substitute AE by EB. So we substituted the AE by EB and we got that AB equals to EB plus EB. That is to say AB equals to 2 times EB. But we have already found out that EB equals to 8 over 3 times square root of 2 units. Okay? So 2 times EB will be equal to 2 times 8 is 16 over 3 times square root of 2 units. So AB equals to either 16 over 3 times square root of 2 units or to 7.54 units. So you can see here that chord AB, this chord equals to either 16 over 3 times square root of 2 units, or in terms of numbers, AB equals to 7.54 units. Okay? Thank you very much.